I'm Alex Wool. I'm a solutions architect. I work for Intel in the Data Center Solutions Group. My focus is on telecom clouds. My background is both in the enterprise and the telecom space, mostly in the cloud computing and data center automation. I've been both on the IT side of the house and on the tools for IT side of the house as well. So. In fact, I kind of like to switch it up every few years, and just so that I can understand what the latest set of problems is. And so the topic we're covering today is zero-touch management environments. We used to call them lights-out data centers, but zero-touch sounds cooler. And so now we're going to call them zero-touch management environments. As always, on the enterprise side, these things have been around for a long time, but this technology and this approach to doing things is somewhat new in the telecom space. And the reason it's even part of the conversation is because of 5G and the IoT use cases. So the 5G and the IoT is yet to emerge in its fullest scale, but there's fear that we're going to have a lot of connected things, connected devices on the network. Some people will say 50 billion, maybe more. If you think about what it means in terms of management and in terms of being able to spin up the services and the network slices on the fly, if you think about all the mobility use cases involved in 5G and IoT, the level of management complexity is going to be pretty unprecedented. It's not an easy problem to solve. As telecom space, as NFV in particular space adopts cloud computing for network as a service deployments, the deployment scale goes across multiple geographies, across multiple locations. So again, the level of complexity goes up as that happens. And for the first time, there's a lot of emphasis on intra or inter-opco collaboration in order to provision different network services. And so again, these kinds of environments didn't need to exist before that much. Now, the worst part of it is that there's a lot of demand in terms of a lot of demands for high degree of fulfillment velocity. We're dealing with situations where somebody is driving a car with a GPS and streaming maybe video and all sorts of other things, and as they go from I guess maybe I need to really hold it close. And as we go from, one region to another, things need to flip over and you're roaming and all of that needs to be flawless and happen in real time. Nobody wants to see their GPS go out to lunch and then come back 10 minutes later. Lots of different use cases around that require very low response time and high degree of background management operation or high velocity of management operations. At the end of the day, all of these things and all of these concerns kind of boil down to cost, right? What is it going to take to support? How do operators make this environment efficient? And how do they eliminate all this different complexity? And if we look at how we manage networks today, it's a very human-intensive task. There's lots of centralized network operation centers, lots of people are involved. It's very much a reactive environment. We still haven't learned how to do things proactively. It's very much a bespoke, very customized environment. Most of the solutions in the telecom space is still based on vertical stovepipes from individual vendors. Everybody's used to buying solutions from a single vendor, top to bottom. Everything is highly coupled, and when you do integrations, there are lots of point-to-point integrations. And so it's a bit of a pain, and really doesn't lend itself to the sort of latency requirements and delivery velocity requirements that 5G will demand. And so virtualizing all these network functions is not going to be enough because, again, the complexity is still there. And so we want to make sure that as much as possible, how we manage networks, how we manage services is simplified and automated to a point where we can eliminate the human error out of the equation. Now, if you think about all the complexity, the more complex the environments are, the more likely people will make mistakes, right? And so the idea is to really, as much as possible, eliminate the human presence out of the loop day to day. Really, the impact of zero-touch management is that we go from we kind of shift, I guess, from a model where we have humans taking care of machines to a mode where machines take care of machines. Some people call this the autonomous data center approach. Like I said, we have lots of names, but in the old days we used to call them just lights out environments. And so what does it all mean? At first it means that a lot of day-to-day operations are not done by people anymore, right? Because again, the degree of complexity and the scale forces automation to take over, so that the fulfillment and the operation can happen fast enough and the latency of the execution is low enough. And so over time we get to a world, and this doesn't happen overnight, of course. Nobody's going to trust, in automation, in one day. Everybody's worried about the Skynet scenario. But over time, the idea is that we want to get to a point where the management functions don't require human presence day to day, right? And there may be some presence, but most of that is going to be focused on oversight of what's going on and kind of holding your hand above the red button that says stop, and not so much doing the actions themselves. And then as you keep running these environments, the hope is that you will gain enough trust, you'll have enough comfort that you don't even need to watch the system. It'll just kind of work on its own, okay? So that's a pretty, for those of you who worked in data centers, I don't know, maybe just for the sake of asking a question, how many people have worked in data centers? Actually on, the data center floors with all the, yeah. And so all the things that people do that we take for granted inside a data center, all the planning tasks, all the things that you use your intuition for, to kind of watch around and predict. All of that all of a sudden goes away, and the intent is to replace all that with machinery. And so just think about that, right? We take a lot of things for granted, what a human mind is. But again, it gets to a point where you can't just keep up. And so something has to take over. So next, we're going to kind of go through some of the challenges that we face with that, and also get into some basic architectural kind of design principles for what these management platforms might look like. So first, the trust part, right? We say trust but verify. A wise man once said that. And really what it means is that you're not gonna go and say, okay, I can go home now and have a cup of coffee while these machine functions run the world. You're going to slowly let them in. And so you kind of end up with these two knobs. One controls the level of autonomy, and the other one controls the degree of trust or oversight, right? You may have a system running at the highest level of autonomy, but you still may want to keep an eye and make sure it's doing the right thing, right? Because you're not trusting it yet. But over time, you will, hopefully, and so then you can kind of dial down the oversight a little bit until you get to a point where the thing is running itself. The data center is basically doing its thing. Obviously, as you dial down the level of oversight, your throughput, your performance of the whole autonomous environment goes up, right? Because you're not really interrupting it to see what's going on and what decisions are being made. So this is key, though, right? Because again, it's going to take time. Every time I do this talk, some people always ask, "Oh, well, what are you trying to do? Put us out of a job?" And then, no, the job changes, right? The job kind of changes more into being able to be in the background and kind of look at the big picture as opposed to dealing with the day-to-day functions. But this is how you accomplish that. And so in terms of basic characteristics or qualities, we kind of have a couple of things happening here. If you get the people out of the equation, then things have to become what I call selfish. Self-configuring, self-optimizing, self-healing, self-protecting, and self-service. So think about a simple task of bringing spares in and swapping out bad parts that everyone in the data center has done. And what does it typically take when people are there? Well, somebody has to go and get the boxes and unpack them and cable up the new machines, take the old ones out, put the new ones in, configure them, do what needs to be done to get them to work right. But in the world of zero touch management, you've got situation where you kind of have to do all that automatically. Right? So you have to do self-configuration. Now that also implies that how we build hardware, how we build systems to support these environments will have to change. Right? You're going to have to build a lot of smarts into the individual hardware components to be able to assess who the neighbors are and be able to talk to those neighbors in an intelligent way and carry on a two-way conversation while you configure the devices configure themselves into existence, or even augment the existing configuration for based on something that just appeared next to them, right? This is not a new concept, by the way. If you look at how Apple does configuration of laptops and printers and all sorts of devices, they've been using something called Bonjour, right, or ZeroConf for a long time. So the concept has been around, but now you have to bring it down to the basic hardware component level and be able to swap it in and out. Again, there's a big question of who's actually going to deliver the components and who's going to receive them if there are no people. So you might imagine all sorts of drones and other things kind of involved in this eventually, a long time from now. But again, it's an incremental process, and so about 10 years ago, I was involved in building one of these lights out facilities for another company in the valley. The vendors would actually deliver the spares by helicopters because the roads were really bad, because the data center was parked right next to a big, huge dam, for cheap power. But they would drop off the spares, and every 2 weeks, 2 technicians would drive in or fly in, and they would replace everything, and then they would leave, and the data center would run on its own until the next repair has to be done. And everything was done remotely, including the basic management, basic monitoring, everything else. And so the idea is that, when you do things remotely, when you do that oversight remotely, you still have to have all the machinery on site working perfectly in order to take care of the basic automation tasks, right? And so you have to start thinking in terms of processes and procedures and making things very predictable, very deterministic, very modular. And so all that starts coming into play. And so you end up with a certain set of operational qualities where, if you don't have these, you don't really have a zero-touch management system. And the first one is trust. And being tamper-proof. You can have all the greatest, machine learning features and AI features and automation in the world, but if you can't trust that environment hasn't been tampered with, you've got problems, right? Now you can't really trust your environment. Now you will never be able to let go. So trust and tamper-proof are the first two that are pretty important. And then everything has to be predictable and deterministic, as I said. There's this principle of least astonishment that we use, to kind of, you never want to be surprised. You want, your automation to do the same consistent set of things all the time under all the same conditions. You don't want to have an anomaly. And then if by chance things do go astray, you want to be able to stop things. You actually need to make sure that that big stop button that you have, behind the glass or whatever, actually works and actually stops, things from going further in a bad way. And then finally, everything has to be available all the time on demand, right? So it's really, what we're looking for here is certainly a cloud-like environment, or a cloud environment, if you will. So the other thing that happens here is the way we deliver software into this environment has to change. So most of the time when you're doing operations, you're going to end up with software being delivered in terms of big products. All companies have products today that have a lot of different moving parts and components. When you build on-demand systems, you can't shut the system down. You're basically making it available 24/7, and especially when you're building network as a service environments that is zero touch. And so the more complex your software refresh looks, and the more you have to do, the more risk you run of breaking things. And so you kind of want to make things smaller and more modular and more functional. And so instead of delivering big, huge products, the idea is to start shifting over to the delivery of software components. Now, in today's world, we think of microservices or little small services as those components, right? And the idea is to be able to continue to evolve those, continue to improve their functionality, and be able to publish them somewhere, like a marketplace. And then allow the vendors or the providers who have deployments that are zero touch to be able to download the changes and deploy them as they see fit. And so what we're doing is creating that separation of concerns when it comes to CI/CD. Okay? But again, the idea is to make the delivery is more service-centric, more function-centric, as opposed to product-centric. Now, what that also allows you to do is have the benefits that marketplaces usually bring about. You could, download something, test it, see if it works the way you want it to, and if it doesn't, then you just replace it with another implementation. And so the competitive landscape is still there. It's just on a smaller scale. And then, of course, the architecture of the whole end-to-end system has to be very consistent, right? It's got to be cookie cutter, and it really doesn't matter if we're talking about the edge or the core or something in between. You kind of want to have this cookie cutter approach as much as you can throughout the implementation of your system. Again, because you want things to be predictable and modular and deterministic. Right? So the smaller the pieces are, the more well-defined the functional boundaries are going to be, the easier it's going to be to replace broken things or find what the problem is and isolate it. And so if we look at what it takes to build an environment like that, the first kind of principle is that the platform has to be model-driven. Right? So if you look at the left side of the screen, this is a typical, set of things that you manage inside a data center, right? From facilities all the way to business processes. This is what IT does, no matter, whether it's enterprise IT or telco IT, everybody has to do these things. And so these are administrative domains. Each one has a model. And that model essentially describes and defines things that you manage within that domain and how things interact in terms of interfaces and what happens. And so what you want to be able to do is apply that to a set of zero-touch management domains, which is a fancy way of saying, well, what do I have to care about managing if I'm building a zero-touch system? Well, I have to manage myself, because nobody else is going to do that day to day. Then I have to manage the resources that I rely on. I have to make sure they're functioning properly and that I have enough capacity to run and execute. Then I have to take care of all the services, all the network services that I'm running as a payload. And then I have to worry about the resources. So these 4 things I have to be able to do. And so ideally, the way you model your payload is the way you would model your own componentry from a zero-touch perspective. The more symmetry you have, the more commonality you have, the more consistency, the more patterns you can establish, the better off you're going to be, because again, small, modular, model-driven things are easy to manage. They're more predictable. Second thing is life cycle, right? You can't just say, oh, I'm going to pick and choose what I do. You kind of have to look at the entire life cycle of different things that you have to be able to operate and manage. And so this is a generic enough life cycle that includes the green stuff. You can kind of, development maybe is more software centric, but for a hardware vendor, it's developing a new system or assembling a new solution, right? There's always going to be something that your vendors are going to do. So that's the part in green. And the part in blue is what you would do. In an automated way. And so there's that point of delivery, and then now you got to onboard whatever it is that you just got, got to test it, got to put it into production. All of that stuff, again, needs to happen automatically with little or no adult supervision from the operators, right? So self-configuration is one thing, but self-optimization, self-assembly, all, and how do you do it securely? How do you trust that whatever you got delivered has actually not been tampered with, right? How do you know that the network functions that you're going to be running that you just received from a vendor have not been tampered with, right? How do you make sure that when they form a chain of VNFs, right, inside your network service, that it's a trusted chain, and then it's running on top of a trusted computing environment, which depends on a trusted hardware, which depends on a trusted network, right? That's the kinds of problems that we're looking at. By the way, this is all kind of early days, and so the expectation is that over time, a lot of companies who are in the OSS BSS space are going to start building solutions here. And so we want to make sure that things don't go in 20 different directions. So there's actually a standards body focused on zero touch. It's a telecom-centric body. It's under the ETSI umbrella, and it just got formed in January of this year. And it's called the Zero Touch Service Management ISG, Industry Specification Group. And what we're trying to do there is to define the actual details of how these hardware pieces find each other and how they interact, how do they configure themselves, how do they self-protect themselves from failure, how do they interact with other systems, and so on and so forth. So if you want to check it out, you don't have to be a member to look at some of the public work. We started publishing drafts of specifications. It's still early days, but the drafts are available to everybody. We made a choice that we wanted to open it up to the industry. And so we're kind of cooking the sausage, as they say, right in front of everybody. So if things look a little ugly, that's because it's only been 3 months. So lifecycle centricity. Next thing is platform modularity. And so what we really want to be able to get to is this environment where you can plug things in, or, take them out, replace them as you go. And so you're kind of looking for what we used to call in the old days a field replaceable unit sort of behavior, right? Except that now you may have software components that need to exhibit that behavior, right? And a FRU or a field replaceable unit, you just kind of plug it into a backplane typically, right? And it's it's a well-defined interface that you have, and so every FRU has exactly the same interface in terms of how it's managed and how it exposes its functions and so on and so forth. And there's been a lot of work done in the industry, actually, in the standard space and the TMF space to create interfaces like that. And the reason why is because they also like modularity, and they also like to be able to build services in a very normative and very well-defined way. But the idea is that you're not just building new stuff, you also have to be able to integrate the old stuff as well. And so you can take a legacy product and create adaptations of that product in such a way that you have a one-to-one mapping, or you can do some refactoring where you take multiple legacy products and combine them together in terms of behavior to create a new interface. Or you can split a product logically in parts and create two different functional interfaces. So again, the idea is that these adapters, these interfaces that you're creating, they kind of define the functional boundaries of things, right? And again, well-defined modular pieces. And then we get to the fun part, right? How do you actually do the thinking, the learning, the adjustments, and the self-tuning and everything? And so in the traditional space, we used to have the typical closed loop automation systems, right? Typically have one for the infrastructure, you have another one for services that you run on top of it. Every Mano stack out there that you have for the telecom space, or every cloud stack, has those two loops. And there may be many other loops inside that big one, so it's a decomposition. But in general, what you're doing is collecting data, you're getting telemetry, you're gaining insight based on what you've collected, you're analyzing it. Based on that insight, you're creating changes or creating plans on how to modify the system, and then you actually execute the workflows that constitute the actions that you want to perform. And so these workflows today are by and large defined by people. The idea is in the future that you can dynamically compose these workflows, again, depending on what the situation is and what you need to do. And again, for that to happen, you have to have well-understood, predictable behavior of different parts. But that's not enough in the zero-touch world, because now you kind of need to go one step higher. And so we end up with this other layer on top, which is kind of new, and that's where you manage knowledge, right? So that's sort of like the high-order brain functions. You can automate the low-level workflows, but what you're really after is the policy-driven approach to doing things. So you got to define the policies, you got to define the basic rules for how things operate. And so the way this would work is that you would have an initial set of policies that would be seeded by administrators, and then based on those initial set of rules, by using ontologies and semantic web relationships, you can start building you can infer other relationships, and you can start building other policies on the fly. This is going to take time. This is what real machine learning really is going to get us to at some point. But today, whatever we do in that space is still going to be fairly human intensive. But again, it's a journey. It's not something we're going to accomplish in 1 year. But the point is that you need that layer in order to provide that kind of global oversight across your services, your infrastructure, and different locations, and different places where you have your equipment deployed, and so on and so forth. And that's not enough either, right? Because what you really want to do is provide more feedback, right? Don't forget the developers. And so you have the development lifecycle, and it's being done based on requirements and prior knowledge of how well things worked in the past. You have that brain, that policy management layer, and then you've got the basic operation and orchestration functions and services and infrastructure. And what you're really looking to do is connect them. So you have these multi-level feedback loops that allow you to not just continue to tune and define and optimize the policies and the workflows, but as you do that, you're feeding the results back to the developers. So they have real-time knowledge of how things are performing. And in some cases, they may be running analytics back in the development environment saying, oh, this thing is about to fail because we've seen these kinds of failures before, and so maybe we need to patch. Maybe we need to improve, how things are done. I'll give you an example of this from, a real world. Airplane engines send telemetry to the factory and to the pilot at the same time when they're in use. The factory uses the data to optimize the design of the next generation or to predict if there are bugs that are about to happen. An aircraft engine is a pretty important piece, right? So, and then the pilot gets a different set of telemetry to fly the plane and to use the engines. But that's the idea, is that we want these software components that are being deployed to actually be self-sufficient enough to keep sending the data back, right? So that, continuous improvement can be made. And so that allows us to kind of become more predictive and avoid the errors, hopefully, before they actually occurred, in the worst possible way. So feedback-driven quality is another very important aspect of Zero Touch. So about a year ago, a bunch of companies got together in Europe, and the companies were from all over the world. And we spent a bunch of time kind of saying, okay, if we're going to build this world of autonomous systems and manage things without human intervention, what would the basic architecture kind of look like? What would we have to do? And how would we make things more modular? And there's no rocket science here. We actually looked at what companies like Google and Facebook were doing. The enterprise world is always ahead a little bit. We have a lot of companies there that operate at web scale, which is even greater than individual operators operate at. A lot of the same requirements are there. And so this was a reference architecture that we defined. There's a white paper that we wrote. And there's a bunch of presentations that were created in order to explain what this is. And if you're interested in finding out more about this, and again, this was highly experimental work. A lot of this was published at the inception of the industry standards group at ETSI, right? When we decided that for the best of all the participants, we would classify this as sort of initial explorations, right? Because not everybody who is participating in the ISG is agreeing necessarily with this particular approach. But this particular architecture assumed a cloud-native implementation. It assumed microservices. It assumed a decentralized federated model where your management plane was not in a single spot, but it was really deployed geographically in a geographically distributed way where the workload components were. And so a very different environment. Now, once we kind of published, the details and all that, one of us found a Google paper. So we looked at it, gee, the slides look a lot the same. So that was okay, and we kind of liked the fact that somebody else thought like us, until we looked at the year of the paper, and that was like 4 years before we got together. So always ahead. But if you're interested in the details, go to the ETSI website. And you can look up some of these initial findings and initial reports that we've done. There's a lot of industry collaboration that happens in this space. We're working with other standards bodies, other open source communities to kind of make sure that we can jumpstart this, right? Because 5G is not that far off in terms of production. And doing this after the fact is going to be a lot more complicated than building something ahead of time that kind of at least can scale or right-size itself with the scale of the 5G deployments. So I think this is my last slide. Yes. I have to display the obligatory notices and disclaimers and all that, and so this is the end. May sound a little bit like science fiction, but again, you know, like I said, this is stuff that's been done and it's been around for a long time. So now we just have to refactor it for the networking space and make sure that it addresses all the regulatory compliance, all the requirements that the telecom industry has that the enterprise doesn't. All right, thank you.